Hello, my dear bachcho. Welcome back. So good to see you all again. I know, exams are right around the corner. And that's why today we are going to do a super quick revision of the entire probability chapter. Bilkul tension nahi lena, okay? I promise you we'll make it super simple. So what are you waiting for? Grab your notebook and let's get started.
So many of you have told me in the comments, Sir, probability se bahut dar lagta hai. It feels confusing, right? I totally get it. But trust me on this one. By the time we finish this quick explainer, all that fear, poof, it's gonna fly away. We're gonna conquer it together.
All right then, let's just dive right in. Now, to really get a grip on probability, you first have to know its basic building blocks. It all, and I mean all of it, starts with something called a random experiment. Sounds complicated? It's not. It's just a fancy name for doing something where you don't know exactly what will happen. You know, like tossing a coin or rolling a die. Okay, next up we have the sample space. I know it sounds like a very heavy scientific term, doesn't it? But really, it's just a simple list. A list of everything that could possibly happen in your experiment. Think of it like a menu at a restaurant. It lists all the options. So for example, if you toss 2 coins, what could happen? You could get 2 heads, a head then a tail then a head, or 2 tails. That list, HH, HT, TH, TT, that's your sample space. Simple, right?
So if the sample space is the entire menu, then an event is simply what you decide to order. Yeah, it's the specific thing, the specific outcome that we're interested in. So let's continue with our coin toss example. Let's say we are interested in the event of getting exactly 1 head. What do? We just look at our big menu, our sample space, and pick out the items that match. And what are they? HT, TH. That's our event. It's just a smaller piece of the whole sample space.
Okay, now for the fun part. Let's meet the main cast of characters in our probability story. You see, every type of event has its own special role to play, and once you get to know them, the whole plot of any problem becomes so much easier to follow. Ready to meet them?
And here they are, our main characters. We have the impossible event, the sure event, the simple event, and the compound event. Now, to make things really easy to understand for the next few slides, let's just keep one single example in our minds. Rolling a single die. What's the sample space for that? Yep, it's S equals 1, 2, 3, 4, 5, 6. Let's see what these characters do in this scenario. First up, let's put the impossible event and the sure event side by side. An impossible event is, well, exactly what it sounds like. It can never happen. I mean, can you roll a 7 on a normal 6-sided die? No way. So that's an impossible event. Now, on the other hand, a sure event is something that is 100% guaranteed to happen. If you roll a die, will you get a number that is either odd or even? Yes, absolutely, you have to. That's a sure thing. All right, now let's look at simple versus compound events. It's, well, simple. A simple event has only one single outcome. So in our 2 coin toss, the event of getting exactly 2 heads gives you just one result. HH. That's it, one outcome. But a compound event? That's when you have more than one outcome. For instance, the event of getting at least 1 head. Well, that could be HH, HT, or TH. See? There are 3 possibilities there. Since there's more than one, we call it a compound event.
Okay, bachcho, listen very carefully now. This next part is a total game changer. I like to call these the super tricks. From now on, whenever you read a probability problem, I want you to look for 3 magical keywords: and, or, and not. Why? Because these words are clues. They tell you exactly what calculation you need to do. First up is the word or. The moment you see or in a question, like find the probability of event A or event B, your brain should immediately think union. That's the U symbol. And what does union mean? It means you take everything. Everything from event A, everything from event B, and anything they share. You just scoop it all up together. Next up, we have and. Now, when the question says event A and event B, it's asking for the complete opposite. It's asking for the intersection, the upside-down U. And this means you only take the part that is common to both. Look at the diagram. It's just that little overlapping section. It's what's in A and B at the very same time, nothing else.
And our last keyword is not. So simple. The not A event, which we also call the complement, is literally everything in the whole sample space that is, well, not in A. So back to our die roll. If event A is rolling an even number, that's 2, 4, 6, then what is not A? It's everything else. The odd numbers, 1, 3, 5.
Okay, everyone,
Pencils down for a second and just listen. Pay very close attention. This is a concept where so many students get confused, but I promise you, after this, it will be crystal clear. We're going to talk about the relationship between two ideas, mutually exclusive and exhaustive events.
Let's start with mutually exclusive. It's a very simple idea. It means two things cannot happen at the very same time. Think about it. When you toss a coin, can you get heads and tails in one toss? No. It's either heads or tails. So getting heads and getting tails are mutually exclusive. Now, what about exhaustive? This means that when you put the events together, they cover all the possibilities. There's nothing left over. So for a die, the events getting an odd number and getting an even number are exhaustive. Why? Because together, they make up the whole sample space. 1, 2, 3, 4, 5, 6.
All right, enough with the theory, right? Let's get to the part that will actually get you marks in your exam. It's time to look at the formulas you need to calculate probability. Think of these as your score boosters. Learn them well, and you'll be flying.
And here it is, the king of all formulas in probability. This is the one you will use 90% of the time. The probability of any event, let's call it E, is just the number of outcomes you want, we call those favorable outcomes, divided by the total number of outcomes that are possible. So for example, what's the probability of rolling a 4 on a die? Well, there's only one 4, so that's one favorable outcome, and there are 6 total outcomes. So the probability is simply 1 by 6. Easy peasy.
And here are a few more hacks for your exam toolkit. First, the probability of not A. This is a great shortcut. It's just 1 minus the probability of A happening. Simple. Next, the probability of A or B. For this, you add the probability of A and the probability of B. But then you have to subtract the probability of their overlap, A and B. But wait, what if the events are mutually exclusive? Remember what that means? No overlap. So that last part becomes 0, and the formula gets even simpler. It's just P of A plus P of B. That's it.
Okay, are you ready? I think you are. It's time to put all this knowledge to the test. We're going to solve an actual question, just like one you might see in your exam. And you're going to see just how easy this can be when you know the rules.
Okay, here's our problem. We're throwing 2 dice. Now listen carefully to the events. Event C is the sum of the numbers is less than 4. Event D is the sum is greater than 11. And the big question is, are C and D mutually exclusive? Let's figure it out. So, what's our first step? How do we even start? We just break it down step by step. First, let's list all the possible outcomes for event C. We need a sum less than 4. What could that be? Well, 1, 1 gives a sum of 2. 1, 2 is 3. And 2, 1 is also 3. Anything else? No. So C is 1, 1, 1, 2, 2, 1. Okay, good. Now let's do the same for event D. We need a sum greater than 11. The biggest possible sum is 6 plus 6, which is 12. So there's only one way for that to happen. 6, 6. Right. Now for the most important step. We check. Is there any overlap between these two lists?
And just look at the two lists. Is there any outcome that's in both set C and set D? Absolutely not. There is nothing in common. Their intersection is the empty set. And what's our special name for events that have no overlap, that can't happen at the same time? That's right. They are mutually exclusive. So the answer is yes. See? You just solved it. It wasn't that hard, was it?
Okay, let's do a super fast lightning round recap of the whole chapter. Ready? Sample space is all outcomes. Event is the outcomes you want. The keyword or means union. The keyword and means intersection. The keyword not means complement. And mutually exclusive means they can't happen together. That's basically the whole chapter in a nutshell.
Okay, my dear bachcho, you have totally got this. See, probability isn't difficult at all. It's just a different way of thinking about things. If you just remember these simple ideas, these keywords, you can solve any problem they throw at you. So bilkul tension nahi lena, you are going to do absolutely great in your exam. I have full faith in you.
But before you go, I have a little puzzle for you. A question to really make you think. Can two events be mutually exclusive and exhaustive at the same time? Think about it. Can you think of an example? Let me know what you think in the comments below. I always love reading your answers. And of course, if this helped you, don't forget to like, share with your friends, and subscribe for more quick revision explainers. All the very best for your exams.